Okay. So for this new session, it's our pleasure to have Michel Buffa here, who's going to deliver a keynote presentation. Michel Buffa is professor at University of Nice Côte d'Azur. I know there is a way to say it, but I always okay. Sorry. So Nice Côte d'Azur, and Michel has been very involved in the web audio community for many years. He's part of the audio group at W3C. And along with people from Mozilla and Google, and yeah, so Michel has been very much involved in the development of web audio in general, and so he's gonna give you a presentation on his latest work, and so please give him a round of applause. Thank you.
Thank you. Okay, there is just my name here, but what I'm going to present is really a community work that involved a core team of about 10 people who made this standard, but also I'm going to show contribution from the whole community. It's not only my work. Okay, I did a lot, but it's not only my work. So first, we will have some fun a little bit later. So if you want to participate with a collaborative application, you take a picture of that. And while I am talking, you maybe stop listening to me because sometimes I may be boring. And you register to there, you create an account, you confirm the email, and you also take a picture or you note the second URL. This is where you will have to go when we will have some fun. I will show again this slide, but at one moment we will all make some kind of participative music using the web browser, and it's just a kind of recreation time that we will have. Okay, so take a picture, or I will show that again, but what takes a little bit long, like 1 minute, is to register, to get the email, to click on it, to enter a code, and things like that. So. Okay, I wait 40 seconds, and then I go on. So it's not necessary that everybody participates, but if we have a few, it's good. Okay, so I didn't put a QR code because the application is not so well suited for mobile device and phones yet. Okay, so I go on. Can I go on? Yeah? Yeah? Okay. I will show that again. So as Romain introduced me, I'm a professor researcher at University Côte d'Azur, blah, blah, blah. He already said everything. Simply, there is here I've wrote some names of the people who helped creating the web audio module standard. So the pioneers were Yari Klemola and Oliver Larkin, who created and coined the name in 2015. And then in 2018, we had a second round of contributions with Stéphane Letz and Yann Orlaré, who are here, and also Romain, I think you contributed. And then we had another round during the COVID where we made the actual version of the web audio module, that is version 2. So web audio modules, what is it? It's VST for the web, if you want to simplify. And what is a VST for the web? It's a plugin that you can use in different applications. And what is the particularity when you want to run something on the web? If you want it to be web aware, and this was my strong contribution, I fought for that. I want these plugins to have a URI like an image. Please, I want to use a plugin, it's HTTP something, and I want to use it. I don't have to download it, install it, unpack it, bundle it. Okay, so this was why I said they are web aware. And they can be instrument, effects, MIDI controllers like virtual MIDI keyboards, they can be parameter modulators, they can be a lot of things, and they can run on many different architecture because it's the web, but it can run outside of the web browser. And this is also a bit fun. So today, this year is the 10 years of the web audio modules. I said they've been created by Yari Klemola and Oliver Larkin in 2015. And with the core team who made that, minus the ones that couldn't have their names on there because they're working for Apple, for example, and they say, please remove my name or I can get fired. So, well, a few people are missing, but it's not our fault. It's because they asked. And this is a 36-page paper that to appear in the GAES journal. It should be, I think, published by the end of the year or maybe the early 2026 because it takes some time to get the revisions and modifications. I created this just half an hour ago with ChatGPT. Thank you. So these pictures, I use it everywhere. It's just a subset of the different web audio modules that have been developed over the years. You can find instruments, audio effects, piano roll, step sequencer, samplers. Today we've got a very large set of audio effects. And well, the instrument set is smaller, but we got very interesting contributions this year with the Prophet 5. We've got the Yamaha DX7, an Oberheim recreation, and original instruments too. So first, before going technical, and I am not sure that there are many web developers in the room, so I will give demonstration and interactive stuff. So we've got an online website that you can build yourself if you download the SDK and build it, where you can try plugins. And what is interesting is that, for example, I can load an audio effect like this. This is the URI. It can be an external URI like this one, for example. And here I am loading a Prophet 5, you know, and it can be used in other applications. This one is a recent contribution. I will talk about it again. But you can have also, well, where is it? Well, this machine is a Marshall GCM 800 recreation. Okay, it doesn't look like a Marshall, but you can use it with some sample. Or you can plug a real guitar. Where is the guitarist? Yes. Okay. So, thank you. So here you've got a classic rock sound like AC/DC, Deep Purple, Jimi Hendrix, whatever. You can try. Or you can try individual audio effects. You can try this one. It's a phaser. Or a very noisy fuzz. Or Vox recreation. Try. Doesn't sound so well so with this one. Okay, so thank you. Later you will come back. And the plugins can be written with different approaches in JavaScript, in TypeScript, cross-compiled from Faust. This is the Faust flute, for example. Okay, and to build this plugin, it's a matter of seconds, really. You launch the first IDE online, you select a flute in the menu, you build, export, and then you can reuse it. Okay, so we've got plenty of different examples. This one is a Juice plugin that has been cross-compiled from C++ to WebAssembly. That is I can select the MIDI keyboard, maybe. Okay. Okay, this is my rubber keyboard, and because I'm carrying it, I've been carrying it for years. Some keys decide to play or not to play by their own will. So, yes. So here we got an Oberheim OBXD, it's the one used in the song Jump by Van Halen. Cross-compiled from C++. We've got some. This thing has been written using React, and it's a small pedal board where you can, well, instantiate different. Okay. Yeah, okay, okay. The sound will be horrible because I choose these things. Okay. Okay. It plays? Okay. Thank you. This one is not so good, but it shows it was a proof of concept that you can build your application using modern frameworks, front-end frameworks like React, that are just with minimized code, building system, and so on. Okay, thank you. Okay, and all these examples are in the distribution, so you can look at the source code, reuse them, and so on. So you've got also plugins for visualization, like this one. Okay, we've got many others, but sorry. And so on and so on. So I'm not going to show you all of them, but what is interesting also is that in the WAM standard, we took a lot of care about performance and optimization. For example, if you want to do automation, let's take any one like that, you can automate any parameter at the frequency rate, and depending on how the host is written and how the this is for testing, by the way, it's for developers. So if I play, you see the automation is done at the sample rate here, and the communication between the host and the plugin is either using standard events proposed by the Web Audio API if you've wrote your plugin with JavaScript. But if your plugin has some low-level part running in the audio thread with custom code, I will talk about this later, then we use shared memory, and it's just a producer-consumer without any memory allocation, and it's super optimized. Okay, so let's go on. So we've got different open source DAOs. So this one, it's developed by my team, and I wrote most of it. So it's called WAM Studio. It's open source also. It has been done. It has been developed as a demonstrator for the W3C technologies. So I kind of prepared the project earlier. If you download the source, it comes with a Docker image. You just have to deploy it on your server, and you will have everything: the backend, the front end, the uploading systems, the plugins, everything. So here, for the moment, okay. Oh, okay. This one I have to play it because I know how to play it. So here I've got a track for my guitar, for example. Just a second. Okay, the guitar is plugged here. You can select the different inputs. I'm activating for recording, monitoring, so you can play. Is the sound going out? Yes, okay. Okay, so if you can give it. And now I'm going to record. And recording real time over backing track. If some of you try to write a DAW to do this, it's quite complicated because you have to compensate the latency, because what you are recording is late compared to what is being played. So at the end of the recording, you must shift back in time to have everything in sync. I don't want the recording to glitch, so the recording has to be done in the audio thread, while the display, the update of the graphics of the waveform is done in the main thread. So you've got to do special things not to have the thing broken. And if I play it back, and so on. So this is in a DAW, and by the way, here when I click, what you see here, that is a sort of pedal board, plugin manager for instruments. You can filter depending on the type of plugins you want. And you can even add your own sources here for plugins. So here it's a JSON file that contains the URLs of the plugins. You can have presets. You can create your own presets, name them, and so on. And this is a WAM plugin that you can reuse in your own application. It's as easy to load as any other plugins inside. And it will hold for you the saving the state, restoring the state, all the asynchronous stuff, and so on. This thing is doing MIDI too. So if you want to do MIDI, you've got to arm something here to select an instrument. Let me disarm this one. Okay, let's go back. I'm going to play stupid stuff here because I'm not a keyboard player. So you can select an instrument. So let's take this one, for example. Okay. And yes, it plays. Can you play something? Okay. You're also a keyboard player. So okay, so I'm going to record. Okay. Okay, okay. So you got the ID, and yes. Okay, you've got the ID. So yes, it's not a DAW as complete as some commercial ones you can find on the web, like Amped Studio, Soundtrap, BandLab, but it's open source, so you can learn from it. And we are maintaining it, adding new functionalities, like we are developing a waveform editor and a MIDI editor right now that are not present. You've got some samples, and it's very easy to add loops here, and you can drag and drop the loops, preview them, and so on. So if you want some loops, yeah, okay. And the whole DAW is a WAM host. And for example, the player that are playing the audio files here, they are a WAM processor. I mean, each track inherits from some classes from the SDK to be able to talk with the plugin while it is playing, to do the automation, for example. The automation is here, so you can automate things. If you do the automation, the player has to talk to the plugins. Okay? And in order to have this optimized, the player is itself a WAM compatible host. Okay, so let's go on. Other people started to develop some hosts, some open source hosts, like this one here. I don't have time to distribute. So in the past, we developed many different hosts. This was a sort of plugin graph playground where you could assemble, draw wires between them. And it was the first time we started to mix plugins written in FOSS, written in C Sound, written in JavaScript, and so on. Now it's obsolete because it was developed at the time of WAM version 1, and we didn't update it. It kind of works. But there is someone I met yesterday. It's Love Bogdanik. Where is he? Yes, there. He said, oh, I've wrote also a host for web audio modules. And, well, he's on the way to do the same thing as I showed earlier with extra features, so you can talk with him. It's also open source, and it's quite impressive. I mean, all the functionalities there. I need to run audio. So this is a synthesizer, an audio effect, and he told me that if I do right-click, yes, you can load. Filters, these are plugins, generators, these are instruments, no, not generators, and so on. And so you can talk with Lovely, if you want more details. So I was so happy, it made my day to discover that somebody is using what we are doing, not only our friends. It's a bit like when you give a gig, and sometimes There are people that are not your friends, that appreciate. You say, oh, well, this is not so bad by the. Okay, so this is time for the recreation time. So I'm going to show you a host that is very particular, and it's one of my favorite. It has been developed by a computer scientist and an artist called Tom Burns. It's called Sequencer Party. It's a multi-participant. Well, I say. MIDI editor, WAM editor, where you can assemble node generators, instruments, effects, and do this collaboratively. And you can have different tracks with different teams working on each track, and we can mix that together. So let me click on it. And I go to my project here, and I created a session for the Linux Audio Conference. So I click on it, and now it's your time. 3 users, 4 users. So let me show again the slide from the beginning. Yeah, if you want to participate, yes, you go there. If you created an account, and then we can start improvising all together. Of course, you don't know the different plugins available. You never use them, so it will be a mess. But I'm going to show you how it works. And this thing is particularly interesting because it works even with low quality connections. Even if you lose your connection, you can come back and catch up and so on, because it doesn't exchange MIDI notes or audio. It just exchange states changes. So let's go there. And where is it? Yeah, it's here. So if you double click, you got a menu where you can start loading web audio modules. So for example, generally we start with some note generators. So the function sequencer is very particular, but I'm going to use a piano roll for the moment. So this is a standard piano roll. It should move on your screen, right? No? Can you see it? Yes, it works. So that means it works. So you can start adding notes. You click on the small square. You can start adding notes. Yeah? No? Can I see that? I don't see any notes. So is it working? Did you click somewhere? Where do you need to show the URL? Okay. Yeah, okay. Let me. Yeah, it's here. Normally, any of you should be able to add, remove, move, connect, and add notes. So here, I need an instrument to make some sound. So I'm going to get an instrument, for example, this one. This is a physics-based synthesizer. Let me zoom in a little bit so that we see that better. And from there, somebody created a delay here. Okay, so the delay, you need to adjust a little bit the window. So let me add some notes here. I'm doing really stupid things. I can click on the right button to connect to the synthesizer. You see the red thing. And you can connect this to the audio output, track output. And if you play, some people added notes. I can hear that. Yes. Okay. And you can start building your stuff. So if you want to add the delay at the end, for example, I can connect this thing to the delay and the delay to the output. And you can start hearing delays. For the function sequencer here, we can go to another track, and you can do this too. You click on track, add track, you click on the link at the top, and here, for example, we can add a function sequencer. Okay, load. And then maybe use another synthesizer, I don't know. Instrument, what can we use? This one. Okay, connect. Then we can connect this to the output and start adding notes. So the notes, you indicate them like that. It's not playing. Yeah, because you need to click this. Okay. And so on and so on. So you can do it yourself, create tracks and start playing. And if you, for example, this thing implements also a lot of extensions to the WAM standard that are meant to add communication channels with the host. So for example, if I am loading a drum sequencer, a drum sampler, for example, here, I can load or save some sample sets. And these are hosted by the host. I mean, we don't have to ask the developer to have his own server for loading and saving what will be recorded and so on. If I am adding the piano roll instrument here, that displays by default the keyboard, if I connect it to a sampler, look at what is happening. The notes are customized because this one implements an extension called Note extension. And this one, when connected, it says, oh, it has a Note extension, and the host is connecting them together, making the exchange possible. And I've got another sampler with a menu, and when you change the sampler set, it changes the notes. Okay, we can have also, if I go back to track 1, I don't think I will have too much time, but if I create some WAMs for video. For example, Butter Churn is a WAM also that implements an extension called video extension. So I can connect this thing to it, and I can connect that to the track video out. No, track output, sorry. Yes. And now I've got things moving in music. Okay. I can use also a WAM for the input video input. So video input is the webcam. Okay. So if I connect this to the output, track output, okay, it's me. But we also implemented some very fun modulation stuff. So in the video, where is it? Yeah, video shader, yes. I think it's that. Let me check. Yes, it is that. And with the video shader, you can connect the video shader to the, no, sorry. We can connect this to the video shader to the output. And then you've got WebGL effects here that you can adjust, scroll, and things like that. And what is fun is when you add this with modulation, modulation one that can modulate parameters from another one, and the modulation is done at the frequency rate. So if I connect this to the, which one? Okay, I think the video shader is modulable. Why don't? Yes, it's here. Okay. If I connect this to the video shader, I can just choose the parameter here, and let's modulate the scroll, for example. And if I do that, okay, let me try. Let's try. And I can smooth the thing. Okay. Actually, I can also modulate things from, I don't know, from the spectrum here. If I connect to it, I can modulate some, the timbre is here, I think, one of these. If I, okay, let me choose that here. If I do that, then you can see that this parameter is modulated, okay? So, I need to go on. What is interesting here is first that all the WAM plugins have a get state and set state method, so you can use them in multiplayer applications very easily. Because the way they are done, normally if the developer followed the good practices and the documentation, the display, I mean the GUI should reflect the changes of the parameters. Okay? And if you just change the state of a plugin, its GUI should follow. So this makes it easy to be used in a collaborative environment. Secondly, you saw some extensions that are adding a lot to what can be done. And with my team of students, we are exploiting that a lot because the extensions are really super powerful, and I haven't showed you all of them. So some of the plugins I showed, like the guitar amplifier simulation, they are open source, but also commercialized by the CNRS, by my lab, and included in some commercial applications. So this is Amped Studio. Amped Studio is a commercial DAW. Oh, can I register? Yes. I haven't been there for a while. So everything changes all the time, including the price. No, it's free, it's free, it's free. It's free, I'm joking. So if I want to record my guitar, I think here I can just go there and look for the distortion machine. It has a different name, but it's the same that is in the distrib. You recognize that. So if I don't know, music somewhere. Okay, if I drag and drop. Oh, format not supported, what is that? No? Yes. Okay, so if I, okay, it's a backing track. It's not a good example, but. Okay. So you can use it like in any DAW, but it's exactly the same code that is here that you saw in the tools for the developers. And yeah, so some people from the industry adopted that. I've got also, I had a PhD student called Xiong Ren, who is the author also of the FOST IDE. And he wrote a kind of Max MSP for the web, a patcher that can include some nodes that are written in FOST, in JavaScript, and so on. So let me just show you what you can do with that. I think I need to activate the sound. So here you've got some WAM plugins. Okay, if I stop that, you got, oh, the flute is not playing. Ah, yes. This is the first flute here. Okay, and so you can have different boxes in the patcher that can be subgraphies and so on, and you can enter FOST code compiled on the fly, and you can, because it's web-based, you can use also APIs for generating music, like generating music depending on the weather, on some data collected somewhere, and so on. I showed that already in the DAW, but it is available. This is the pedal board host. It is available as a standalone plugin, and I don't remember what was its URI, but maybe it's that. No, yes, it's that. So you see, if I take this and put it in the same software I showed earlier, you can load it, and by just adding one source or multiple source for the plugin, okay, it's not the right one. This one is broken. Maybe this one? Yes. Okay, loaded, and now it's full populated with plugins, and you can add as many sources as you like. It's just a JSON file with URIs. And you can use, well, I don't know. This is a sampler. Okay. So let's go back here. Yeah, and they are available in the repos also. And this I showed already, loaded in the DAW. Okay, so about the guitar arm simulation, I need the guitarist again. Okay, so we showed this is for classic rock blues, etc. But we've got some different other guitar arm simulations. So for metal, for simulating, okay, this is for blues. Can try. Okay. Show us what you can do. Okay. Sorry. yeah, we got some prizes for the tube simulation that is provided. And here it comes with different models. You can try again. Okay. Okay. Maybe I can put... Okay, try the metal one, this one. Ouais, non, vas-y, vas-y. Essaye celui pour le métal. Tu fais du métal. Okay. And now, acoustic guitar simulation. Mets-toi sur le micro aigu, baisse un peu le volume. Aigu, aigu. Baisse un tout petit peu le volume. Vas-y. Et joue des trucs. Remonte un peu, voilà. Okay, the sound is not so good. Ah, okay. I didn't touch that. Okay, so here we try to emulate an acoustic guitar with an electric guitar. Il n'y a plus rien. Faut pas attaquer fort, faut jouer. Okay. So not so convincing here, but I got plenty of videos that shows. They've been tested by professional, amateurs, by plenty of people try that. And thank you. So, default preset. Yeah, okay. Okay. So yes, you can. If you click, you can see plenty of user testing of these tools. Okay, and well, let me talk a little bit about this thing that you showed earlier. It's called a function sequencer, and why is it called a function sequencer? Because it includes a code editor, a source code editor. It includes Visual Studio Code. So if I go back to the demo we had. Maybe it's still active. I don't know if you kept playing with that. But yes, loading. And it doesn't load. Am I offline now? No? Reload? Okay. Is it working for you? It's just slow. Okay. So let me explain. So if you click, there is a button called Code here. And if you click on it, you can start live coding all together at the same time, some parts of the function sequencer, and you can make it look completely different, generate notes randomly, for example, or we implemented a Turing machine, a drum sequencer, a function sequencer. We've got something like 5 or 6 presets different that gives to this thing a different look. So you can have a programmable, collaboratively programmable MIDI generator, MIDI note generator. And at the beginning, it was Tom Burns, the author, we made some presets, but with him, I remember we spent 2 evenings coding different note generators. So is it, no, okay, it's broken on my side, I don't know why. Is it just the web that is broken or the session that is broken? No, okay, it works. So yeah, I said here if you click on code, you've got a source code editor, and there is a documentation, of course, and where you can create GUI elements, event handlers, and whatever. And if we are multiple users at the same time, it works, and you can switch from the code to the GUI, and there is an error console, and you can build this. It's not for anyone, but it's useful when you want to enter this among some expert developers that want to contribute. And this is using another WAM extension called collaborative extension. Okay. In collaborative WAM host, the patch can be edited simultaneously. We've got sampler, so I showed it earlier, but let me just show you a small demo, maybe. This sampler is interesting because you can look for sounds on free sound. There is a search engine. So I looked for a dog, and I can create a note set with the dog sounds. Oh, I think something is playing here. Stop. Yes. Okay. So I started to make some sampler with and then you can drag and drop the different sounds, and you can trim them. You can add some effects, and you can. Okay, this is the note set of with the dog. Okay, okay, let me go a little bit further. I think I'm making the cats or the dogs play after that, after a while. No? Okay, I don't remember what was in the video, but you can make concertos with cats and dogs very easily. And it uses free sounds. You need just to enter your API key in a field, and you can save it. Okay, so time is going on. Let me continue. Yes, also people are using WAMs with P5. I don't know if you know P5.js, it's processing. And it's very easy to load a WAM in 5 lines of code. If you click here and look at the example, you will have at the beginning, okay, example for loading a WAM, it's just 4 lines of code. And then you got the WAM that appears. And it's interesting because it shows how it can be used with interactivity. So here, the collisions are generating notes. There is an orbiter here that is modulating the filter parameters here. And you can use the piano roll to make some sound. You can turn on or off different effects, change the preset, and so on. So this was a proof of concept, because here the orbiter modulator was done by ChatGPT during a meeting that was super boring for me. So I just generated some code and tweaked and pasted that here. And it was a proof of concept. All these things at the bottom here were done in less than 1 hour. And it's in the animation loop that 60 times per second. I'm doing set parameter. But this is not the right way to do that. But it was a proof of concept. And then we use that to develop some orbiter parameter WAMs that do that at the sample rate. I will show that later. There was also some famous instruments like the Victor NV1, okay, that was available on the web, and we ported it to. Oh, no sound? Ah, yes. Okay. So this was a famous synthesizer that was published in 2016, I think, and it has been ported. I showed also the Prophet 5, the Oberheim, and one researcher from Sweden called Hans Lindetorp is also using something he developed called WAXML. It's declarative XML. So use that with students in high school. And there is an example, I think, here. Yes, maybe this one. So this is P5. And you can use web audio module directly. Okay. You can use that with a declarative syntax, like a bit like HTML, and he thinks it's easier for the young students than using a syntax that looks like programmation languages. I think he had another demo that was more fun than this one. Let me check. Because it used MediaPipe, the MediaPipe library for generating things when you close your eyes like this, you know. So he's piloting, I don't remember how it works. I think maybe we need to plug the guitar. Okay, but you got the ID, so it's very easy. The whole code is here, you see, for this kind of application. So he published a paper, several papers explaining what he called the web audio learning objects. And now he integrated the web audio modules in it. So, okay, so the WAM extensions, you saw already many of them, but there is also a 3D extension for animating 3D shapes. For the moment, it supports 3GS, the JavaScript library 3GS. I show that this is the note extension for customizing the notes in the piano roll. This is the video extension for WebGL shaders. This is the asset extension for loading and saving assets. There are examples you can click, but I don't have time. The modulation target extension allows any WAM to modulate other parameter WAMs. I show that with the video and stuff, but here we've got a WAM. On the top, it's a WAM you can reuse. And on the different corners, you select the parameters of the targets you want to modulate. And you can change interactively. These menus are populated automatically when you connect them. Okay, and because it's not enough, we are doing this also in 3D. This was my presentation from 2 days ago at the GYM conference. So because the WAMs can be used headless without a GUI, that means that you can also create your own GUI in addition. So we created some 3D GUIs. So this is a first guitar synthesizer, and you can see different people connected. This is the piano roll with a 3D interface. It's exactly the same code that I showed with the white and red one previously. We didn't change any line of code. We just use it from the URI, and from the URI we just associated the new interface. And from there, you can it's a port of sequencer party principles ID in 3D. It's an ongoing work. And in order to build the interfaces, we've got an editor. I don't have time to show you this extensively, but you can use any URI from the, oh, sorry. Sorry. Okay. From the, I need to click on YouTube. Yeah, from the URI, you can, you enter the URI, and then the plugin is loaded. And from there, you can start editing a 3D GUI. And when you add some controllers, you can choose in the drop-down menu the different parameters you want to associate. And you can really texture it, add the 3D labels, add the MIDI connectors, audio connectors. I'm doing this very quick. And you can create many fun shapes. This is a voice synthesizer written in Faust. And I asked my students to be able to do a guitar. So this is how you do it. In real time, it takes less than 5 minutes. Okay. So and this is the guitar you saw in the 3D example. Different shapes. So we built something like 20 3D plugins like that. And the editor is also available online. So go to look at my paper from GYM about that. And yes, and we are also, you can customize even better the 3D GUIs by adding some code. So we've got a sort of SDK where if you want to do 3D animation, or if you want to, for example, with a drum kit, you want to make the cymbal, rotate around the axis when they are hit using a physics engine, you need to write code. And this is the 3D orbiter. The port of this plugin is used here, but in 3D.
Allô, aujourd'hui, je vous montre les 3 meilleures progressions d'accords de tous les temps. C'est les 3.
Sorry. I don't know what happened. Yeah, okay. So here you've got this thing corresponds to the parameters of the 2D thing you saw, and it changes the parameters of the curve, and there is a the sphere in 3D that is orbiting, and it modulates at the audio rate this parameter here. Okay, so you can see that the WAMs, they can be used in different environments, and here we are using the same web audio modules without changing any line of code again. We are just using the URI in a Raspberry Pi without any web browser, because some people from IRCAM, they just recreated, re-implemented from the specification the web audio API, and they took also the WebAssembly engine that is available in the browser, and they provided them as NPM modules for Node.js. So we've got a Raspberry Pi 4 with a IFI sound card, and we just run directly the web audio modules. So these are early results. This is a delay effect with maybe something else, I don't remember. Okay, the latency is not super low, but it's playable. An Ottawa. Yeah. So, we are working towards an effect pedal built on that. And what is interesting is that all the pedals, if you have several Raspberry, they can be connected together and synchronized. So we plan to have also some instruments synchronized together running on this thing. Sorry. So a little bit into details. I know you're not. It's not a web developer conference, but the web audio API is in your browser, and it's written in C++ or in Rust, and it provides sound processing running in a very high priority thread, like usual when you are using sound generation libraries. This is the case. And from JavaScript, what you write is just how to assemble this graph, how to set the parameters, and this is running in the main thread. When I recorded the guitar earlier, all the recording is done in a very high level, very high priority thread, while the displaying of the waveform and the buttons is in the main thread. This is if you are audio developers, you know what I'm talking about. Okay, so Web Audio API since 2018 support custom DSP programming with something called an audio worklet. That means that you can write your own code that will run in the audio thread, and usually, not always, but usually it's WebAssembly code that is running there, because it's a bit cumbersome to write low-level code in JavaScript. Some exceptions is the track player that I talked about, you know, in the DAW that I developed with my team. The track player is a low-level player, but it just looks at input some samples and copy them to the output. Okay, so we did this in JavaScript, and we added some code for the automation or for sending MIDI notes and things like that. But it is now possible to write low-level code, and if you don't go there, because it's a bit complicated, if you are just a web developer, you will miss a lot of possibilities. And to tell you the truth, I'm not too good there, but I use FOST for generating that for me. I use C Sound or C Major to generate this for me. And when we designed the web audio module standard, we tried to please all the web developers, because the web developers, they like to use new things every three weeks. There's a new framework, a new deployment tool, a new building tool, a new something. So we had to be able to deal with that, okay? So we did our best to support everything. People who like to develop using NPM modules, people who like to use declarative stuff without compiling anything, and so on. But the audio developers, they are another kind of beasts, because for them, if it's not C, C++, it's crap. And Or maybe it should be a domain-specific language that is so niche that ChatGPT cannot generate anything. Yes.
Juste, c'est moi. Je suis là.
Yeah.
Just to tell
minutes.
you, there's
Yes, okay,
5 minutes left before the end of the session. So either you take questions or you continue.
Okay,
but
I will stop here because you're not audio developer. So about the development for... So there is an official website called webaudiomodules.com. You start from there and you send me an email. Like this, I can give you also other information because the resources are a bit sparse. I did my best to centralize things here, but I know there are plenty of other resources available that I can point you to. And I will share the link to this presentation, and you've got all the links to the tutorials, to the different resources. So, yeah, there is a conclusion. Let me go there. Yeah, there is a conclusion. Okay, it was too long. Yes. Yes, so you can join us on the Slack web audio channel, on the Discord, the audio program app with a sub-channel web audio. We are there. Stefan Letz is there too, and we can answer your question. So, yes, questions. Don't tell me.
Thank you. If I ever need to synchronize a piece of software running in a browser with web audio modules with another one using something like, let's say, Ableton Link, how would I do that? Because I don't think that UDP is available in the browser ecosystem.
So if you want to link native applications with a web application, there are two ways. Either you have a third-party server that will serve as a proxy, but this sometimes is well, you have to develop the server, you have to deal with that. There is another approach that is not as seamless for users. It's to do what I call the reverse web approach. So you have your own web server running locally on your machine. Then your web server has access to all your hard drive, to everything, can talk without any limitation to any native applications. Okay? And because it's running on localhost, your own, the web application can access it. So, for example, in Amped Studio, you can run VSTs directly in the track with the tracks of your online DAW. You can process the sound real time. You can play guitar with Guitar Rig, Amplitude with native plugins. It works. The thing is that if you save your project and you send the URL to someone else, you will have you will need to have the same configuration. Okay, it won't be seamless. But there are plenty of examples of people doing reverse web approach when you want to do, for example, the presentation from this morning with Godot and so on. It could be done using this approach if you want to link native applications.
What if I want to link web applications?
What if you want to connect other web applications? Okay, so in this case, if they are on different domains, you will need a common server. You will need a common endpoint that is doing WebRTC or WebSockets or something like that. Yes?
Hi, over here.
Yes.
I guess the elephant in the room is latency, and it was pretty amazing that I could hear the picking noise of the guitar and hear no noticeable latency to the audio results. And I just wanted to ask, is that something that, I mean, it's a demo situation, you know how to set up your system, but is that something that is very easily to achieve? Would it be easy to achieve on a Chromebook or low-level hardware? Or?
Easy answer, because it was, I struggled with that a lot in the past and recently too on Linux. Okay, so on the Mac, it's out of the box, okay? The browser, Firefox is more optimized than Chrome. I use Chrome for convenience use, but it works on Firefox pretty well. The latency on the Firefox with a 128 sample buffer is 17 milliseconds. And if you take Logic Audio, Ableton, and with the same kind of applications, and you measure the end-to-end latency, I mean with a microphone on the body of the guitar and in front of your speakers, I did that, you got exactly the same results with Firefox. With Chrome, it's 6-7 milliseconds more, but it's really playable. And when I mean playable, I had the Megadeth guitar player, Kiko Loureiro, recently, who played with the amplifier simulation. I was so scared because the guy is between 1 and 2 million notes per second. I was so scared that the software wouldn't be able to handle that, but now it works. With Windows, it works also, but you need to install the proper high-definition driver from the maker of the sound card, and Windows likes to replace that by a crap driver behind the scene with each update. But it works. On Linux, a few years ago, I came to IRCAM to make some demonstration, and with a Linux box that belonged to Guillaume Pellerin, a researcher from there, it worked out of the box, but he had configured his machine. And for this conference, I've got in my suitcase a Linux laptop that I just installed Ubuntu Studio, but no, I didn't manage to have a proper latency. It was not playable. And I did my best, looking on the web, asking ChatGPT to configure Pipewire and Pulse Audio with config files for low latency, running the browser with some flags, but I couldn't achieve that. Unfortunately, I'm leaving at 2 o'clock today, but I would have liked some geeks from the room to help me achieve a low latency. It is possible because I did it in the past.
I think we have time for one short question. Yeah.
What about tablets, for example, iPads, and in particular, does it support like multi-touch on a tablet?
Okay, this is not the Web Audio API. Yes, the multi-touch is working pretty well on tablets. Thanks to the Pointer Event API that is available now. So there is a Japanese developer who is making a web audio application especially for multi-touch, and this is not a problem. With iOS, the problem you've got is Safari, okay, because Safari is not supporting MIDI for the moment. And Apple, unfortunately, they say it's not our priority, so maybe it will take 3 years, I don't know, before it comes, or maybe never, or maybe tomorrow. Apple is quite opaque about what they are doing. And if you run Firefox or Chrome on iOS, it is Safari behind the scenes. This might change because I saw that there are some European community laws that will try to force Apple to allow third-party browsers, web browsers. But for the moment, you've got to deal with Safari. So everything works with Safari except MIDI input.
All right, thank you.
All right, I think we can give another big round of applause for Michel.
Okay. Thank you.
So we're going to take lunch break. There are rules. I need to warn you about them, and they're important. Those of you who got a lunch ticket, you can follow us and go to the dining hall. If you don't have one, you don't go because you cannot pay there by card, okay? You need the ticket to go to the dining hall, and there is nothing that we can do about this, okay? I'm sorry about that, but it's pretty strict, okay? If you don't have a lunch ticket, there are places not far away where you can eat. I sent them by email to you like 2 weeks ago or something like this. There's like a Universe Cafe, and they have like kebabs and pizzas and healthy food. But those of you who managed to get the lunch tickets, we can meet outside of the conference venue, and we can walk together to the dining hall, and we'll resume sessions at 2 p.m. Thank you.